So this is a discussion of Venus and Mars. Venus is the second planet from the Sun. It's inside the Earth's orbit towards the Sun, and so that's planets that are inside the Earth's orbit. Mercury and Venus are often called inferior planets. Mars is just outside the Earth's orbit. It's 1.5 astronomical units from the Sun, so it's compared to Earth's 1, and so it's called a superior planet. We'll talk about that as we go. We're going to begin by just giving a few general properties of each. Let me just see if I can page down here. And so you can just look on the left, here's the property, and then it's Earth, Venus, and Mars. The semi-major axis, the Earth's semi-major axis is 1, Venus is 0.7, and Mars is 1.5. Just for a brief review, the semi-major axis is so here's, if this is the Sun, if this is the star, right, and this is the orbit of the planet, I'm trying to draw it in an ellipse, even though all the planets' orbits are much more circular, and I'll get to that in a second. The long axis of the ellipse is called the major axis, and so so half of the major axis would be the semi-major axis, and that's what they're showing in the table there, the semi-major axis. In fact, all of the planets have very nearly circular orbits. None of them are elliptical like this. So you almost can't tell its ellipticalness from a circle. And so when we're talking about the semi-major axis, even though they use that formally, really you can just think of that as the radius of its orbit. Let me switch back here. And so, you know, Earth is 1. The definition of an astronomical unit, which is the unit of measure we're using for this, is the Earth is 1 astronomical unit from the Sun. And on that scale, Venus is 0.7 and Mars is 1.5. The period of each of these, as measured in Earth years, obviously the period of the Earth, the period is the time it takes to do one orbit, right? So obviously the period of the Earth is going to be 1. Venus is an inner planet, so it goes faster, and so its period is 0.6. Mars is a superior planet, an outer planet, so its period turns out to be a little under 2 Earth years. You can compare the masses of these. Notice Venus and Earth are pretty similar, and Mars is about significantly smaller. Same with the diameters. Diameter of Earth and Venus are about the same. Mars is about half as big. Densities of Earth and Venus are about the same. Mars is down maybe 25% or so from that. Surface gravities are similar to those. Escape velocity, we don't talk about that. So the rotational period of notice in this case, most of the things we've been comparing, Earth and Venus are similar, but now you see that in terms of rotational period, that's how long it takes the thing to spin once on its axis, right? The Earth is about 24 hours, and Venus is about 24 hours. Mars is about 24 hours also. Venus is 243 Earth days to spin one time on its axis. Venus is barely turning at all. All right, surface area is about like the diameter of the planet, roughly speaking, comparable to that. The other relevant piece of information is the atmospheres. These are all critically different here. If the Earth's atmosphere is measured as 1, we call that a bar. Then Venus's atmosphere is 90 bars. It's got 90 times the atmospheric pressure that we have. You would have to go down about half a mile in the ocean to feel the kind of pressure that you would feel standing on the surface of Venus. By contrast, so Venus, you know, I'll usually say, if I'm just casually talking, I'll say Venus is about 100 times the atmospheric pressure of Earth. And I'll say Mars is about 1/100th. It's actually more than that. It's about 140th the pressure of Earth. So Venus has a very heavy atmosphere. Mars has almost no atmosphere. I hope I'm saying that right. Here's a picture. So we'll start with Venus. I'm going to go over a few things about Venus, and we'll talk a little bit about Mars. So if you look at Venus, you can't see its surface because it's covered with clouds 100% of the time. All of Venus is completely covered with clouds. And so its surface has been mapped by space probes using radar, which will let you see through clouds. Venus's surface temperature is about 860 degrees Fahrenheit. That's day and night. evening and weekends, summer and winter. It's 860 degrees Fahrenheit on Venus. It's by comparison, a wood fire is about 450 degrees Fahrenheit. So this should give you a clue about why we don't have any probes on Venus. It's just too hot. The pressure is too high. It's got acid in the atmosphere, which we'll talk about a little bit. So we have lots of probes on Mars because Mars is just cold, and electronics can handle that, but they can't handle being set on fire. So observing this Venus, after the sun and the moon, Venus is the brightest object in our sky most of the time. And that's a little surprising because it's not a very big planet compared to the outer planets, for example, but it's bright for a few reasons. One is it's near the sun, so it's getting a lot of sunlight. Two is it's close to Earth, and so it's bright and it's near us. That helps us see it better. And finally, it's covered with clouds, and so it's very reflective. If you've ever gone outside on a snowy day after the sun has come out, so the snow has stopped, the ground's covered with snow and the sun's shining, the Earth looks very bright when it's covered with snow. And it's the same thing with clouds. When you have a lot of clouds, planets are very reflective. And so the Earth, Venus, because it's so cloud covered, it reflects about 75% of the light that comes to it back into space. So it makes it very bright when you're looking at it from far away. The moon only sends about 17% back, Mercury 12%, I think Mars is about 15%. And so Venus is bright for a lot of reasons. Venus' surface and interior has a mantle similar to Earth's. Its surface, however, is different, whereas Earth has continental plates that can differ in elevation, from the top of a continent to the bottom of an ocean basin. It can be as many as 5 miles or more. Venus is much more like a single plate with only small, maybe a mile top to bottom variation in elevation. Venus is geologically active as the Earth is, so it has quakes and volcanoes. But instead of having rift valleys and subductions, instead of having moving plates and subductions, it does kind of have rifts. Venus wrinkles, and so when it's like you take 2 blankets. Maybe I can go this way. Maybe I can try this. So if I take my cleaning rag, right, and if I have a plate on Venus and it's moving this way, it tends to want to wrinkle. If these 2 guys are going this way, whereas on the Earth you get subduction, you get one passing under another. Venus just kind of wrinkles up as the plates move towards each other and tears as they move apart. Uh-oh. All right, hang on a second. F3. Geologists believe this is due to the fact that it's got a hot, dry surface. It's very hot. It wrinkles easier and it's dry. There's not a lot of water in there. That affects its stiffness. I'm getting there. There we go. Here's some pictures of wrinkles on Venus. So you can't really send probes to Venus, but it's been done. The Russians did it in about 1980, and you can Google Venera 13 and Venera 14. I think they both landed, if I'm not mistaken, and took pictures for a few minutes. From what you can see in this picture, it looks like volcanic plains, right? And there are other pictures you can see. There are not too many surface features on Venus. But there are some. Craters are a good indication of age of a surface. If your surface has a lot of craters, it hasn't been renewed recently. The moon is covered with craters. It's got no geologic activity. Its surface is very old. The Earth, on the other hand, is constantly renewing its surface. Venus is somewhere in between. It has more visible craters than the Earth, but way fewer than, say, Mars. And so Venus's surface is older than the Earth, but it's a lot younger than Mars's surface. And Venus still has considerable geologic activity. These are some volcanoes. We occasionally catch Venus's volcanoes in action, not by seeing them because we can't see through the clouds, but we can detect things that happen in its atmosphere to let us know that there's been an eruption of some kind. A little bit of atmospheric data on the 2 planets. There's some interesting stuff, I guess on the 3 planets technically, since we include the Earth. If you look at the composition of the atmospheres, Mars and Venus are actually very similar in terms of their composition, right? They're 90-something% carbon dioxide and a few percent nitrogen and not much else. Of course, Venus's atmosphere is so much more dense, it has a whole lot more of this stuff than Mars's does, but in terms of their overall composition, they're very similar. Earth, by contrast, is very different from those two, right? Earth has almost very little carbon dioxide. It still has a strong influence on our environment, but there's not much there. We have mostly nitrogen and considerable oxygen, which comes from our biosphere. These guys have very little oxygen, at least partly because they don't have a biosphere. Here's a picture of the temperature profile of Venus. You can see that most of the heat is coming from its troposphere, which is, I think, 30 miles deep or something like that. Yeah, here it is, about 30 kilometers on the left. No, yeah, 50 kilometers to the top of the clouds. And so it's about 30 miles, whereas the Earth's troposphere is about 8 miles or something like that. And this is what's trapping all the heat. The temperature on Venus is about 860 degrees Fahrenheit. This is the day temperature and the nighttime temperature. And like I was saying, winter, summer, spring, Venus really doesn't have too much of that. It's considerably hotter than Mercury, and Mercury is almost half again as close to half the distance from the Sun that Venus is. The difference is Mercury has no atmosphere. And so the dark side of Mercury cools off at night. It radiates away its heat, and it gets extremely cold at night. And I think Mercury's daytime temperature is about 600 and something degrees Fahrenheit. But it's in the negative hundreds in the nighttime. Sorry, its daytime temperature is about 600 Fahrenheit. Its nighttime temperature is extremely cold on Mercury. Not so on Venus. Venus has a big, thick atmosphere. It traps heat. It's there all day and all night. So it turns out that Venus is a victim of the runaway greenhouse effect. And I'll sort of explain that here sort of briefly. Astrophysicists that believe that Venus once had oceans like Earth does. How planets got their oceans is a subject for discussion, but probably they were delivered by objects like comets, which are icy objects from the outer solar system. Anyway, there's several different possibilities, but all of us had water. All of us terrestrial planets were delivered water at one time or another. We still see we find water on the moon, for example. It's frozen in the bottom of craters, but it's there. So it had water at one time. But the problem is, as the sun aged, the sun got hotter. As the sun got older, it got hotter. And this increased temperature caused Venus's oceans to begin to evaporate into its atmosphere. And as that happened, water is also a greenhouse gas. The temperature increased. As the temperature increased, more water evaporated out of the oceans. And this is called the runaway greenhouse effect. As the oceans get hotter, more water evaporates, which causes the oceans to get hotter again. It didn't have enough sort of inertia like the Earth does to keep it cooling back down. And so eventually the sun got hotter and hotter, the Venus got hotter and hotter, and eventually all of its water ended up in its atmosphere. And of course Venus's continuing volcanoes and geologic activity continued to produce CO2, which also got trapped in the atmosphere and wasn't getting washed out by the rain, that wasn't condensing back into the ground. And so Venus got runaway hot. Ultimately, ultraviolet light from the sun has split the H2O molecules, and the hydrogen molecules, when they get split, are hot enough that they can just leave and go into space. And so Venus not only doesn't have not any water on its surface, it has almost no water in its atmosphere as well. And it's extremely hot. That's the runaway greenhouse effect. Okay, let's talk a little bit about Mars. This is a picture of Mars taken by the Hubble Space Telescope. It's just a nice picture. You can get pictures like this from not quite this good, but almost from a regular telescope. You can see some features. So we can see Mars has polar caps. You can see those with an 8-inch telescope. We see them if you catch Mars at the right spot, and we'll talk about that in a little bit. So you can also see some of these other structures. There's some surface features on Mars which are kind of interesting, which we'll get to. Mars has some very large volcanoes, and you can see a little structure in Mars when you look at it, unlike Venus, which just looks like a white dot when you look at it through a telescope. There's an interesting story about a guy named Percival Lowell, who was a wealthy man in the late 1800s and early 1900s. He he imaged Mars a lot. He did drawings, and he decided that there were canals on Mars. It was sort of a misunderstanding. A guy named Schiaparelli, an Italian guy, used the word canali, which means channels, but Lowell took them to mean man-made canals, and so he argued that there's agriculture going on Mars with canals and things like that. It was a big deal in the late 1800s, early 1900s, and it gave rise to these stories like War of the Worlds by H.G. Wells, and all sorts of Martian stories. There was no truth to it, of course. The things that he was seeing were sort of, some features just on Mars. You saw what it looked like a minute ago. You can use your imagination at various times. Mars has interesting weather that can occasionally make things appear a little funny, but now we have probes, of course, going around on its surface, and we can know what that looks like. Oops. So here's a little Mars data. Mars is the last terrestrial planet going out from the sun. It's about 1.5 astronomical units from the sun. A warm day on Mars would be 70 degrees Fahrenheit. A cold night would be minus 200. This is nice, by the way. We already said it's got almost no atmosphere. And so, our electronics can handle this sort of thing. So it's easy for us to put probes on Mars. There's not much air there. That's okay. Our electronics don't mind that. And the temperatures are cold. Electronics typically don't mind cold temperatures. There's some challenges, but it's much better than being hot. Its year is about 687 days, or a little under 2 Earth years. We talked about that already. Mars has a 25-degree tilt in its axis, very similar to Earth's. Its diameter is about half Earth's. Its density is, we already talked about that, about 75% of Earth's density or something like that. Its reflectivity is about 15%. That's what albedo means. So earlier I talked about Venus reflects about 75% of the light that hits it. What this means is that Mars reflects about 15%. 0.15 is 15%. Its atmosphere, we've already said, is mostly carbon dioxide and nitrogen, water, and some other things. Dang it. So let me just talk about the orbits just for a minute here. Venus and Mercury have orbits that are inside Earth's orbit. And so they're always within a certain angle of the sun. So I'm going to switch over and draw this for a second just so that we can understand the geometry of this a little bit. So let me do that. And let me get my eraser here. This. So let's say this is the sun's orbit, right? And we're going to make a big circle here, and we'll say that's the Earth's orbit, right? And I'm just going to pick one of these guys. It doesn't matter. We'll talk about, well, let's say this is Venus's orbit, something like this, right? And then I'll say this is Mercury's orbit, right? So let's say the Earth is here, right? So Venus goes around, here's the sun, right? Here's the direction of the sun from the Earth. Venus can only get about that far or that far as an angle from the sun. Venus is limited in how far it can appear from the sun, and Mercury is more limited, right? And so these angles are called, this is called the angle of maximum elongation. This is why, even though Mercury, for example, is a very bright object, people almost never see it. Most people haven't seen it because it's either up just an hour or so after sunset before it sets. If the sun goes down, then Mercury goes down an hour later, right? Because if the Earth is turning this way, say, right? So let me redraw this for a second. Draw this. Let's say this is the Earth, right? And over here is the sun. The sun is that way somewhere, and Mercury is this way. So here's Mercury out here somewhere, and that's the direction of the sun. The reason Mercury sets is because the Earth is turning this way, right? And so right at sunset, I'm standing here. I know this isn't a scale drawing, right? I'm standing on the Earth, right? And the sun is in my western horizon. The Earth is turning this way. And so right after the sun sets, I see Mercury up there somewhere. But then the Earth keeps turning around, and in an hour or so later, Mercury is on my horizon, right? I'm standing here somewhere, right? And now Mercury is on my horizon. I don't see it anymore. And so it's just an hour, maybe, or two, before Mercury sets. And then it's the same thing with Venus, except a little more. And so they're always sort of just above the horizon, or maybe well above the horizon, but they're never over here where you're overhead at midnight. So let me just go back and draw a slightly different picture of that. So here's the sun again, right? Now we'll draw Earth here, and I'm going to draw Mars out here. And I'll come back to this in a minute, right? If this is the Earth and this is the Mars, I can be standing here, and I can see Mars overhead at midnight. So let me go back to the earlier picture here. Right. So the maximum angle that Venus is from the sun is about 47 degrees, and the one from Mercury is about 28 degrees. These planets can't ever be overhead at midnight because they'd have to be on the opposite side of the Earth, and they're inside the Earth's orbit, so they can't do that. So, unlike Mars is the first planet we're talking about that has an orbit that's outside ours. What does that mean? It means, unlike Venus and Mercury, it gets to be on the opposite side of the sun from us. And so that's called, that position is called opposition. Right? If this is us, and the sun is this way, if the planet's this way, they're in opposition. And you notice, like, no matter where Mars is in its orbit, that's the closest it's going to be to us when it's at opposition. And so this is the time you want to look at Mars, right? You want to look at Mars when it's at its closest to us. If Mars was over here somewhere, it'd be really far away. You'd be looking at a much longer distance than this one. And so this is the time you want to get your telescope out and look at Mars. By the way, the next opposition of Mars is in December of 2022. So they happen every 2.5 years or so. Also, if you want to send a probe to Mars or a spaceship to Mars or a person to Mars, this is the time you want to send it. In fact, usually when the Earth goes around faster, and so when the Earth is like over here and it's catching up to Mars, you want to launch your probe right about there. And so if you ever watch science shows on Mars probes, they'll talk about having a 2-week window to get the probe launched, and if they don't get it launched in that window, they have to wait another 2.5 years for it to come back around, so it's catching up to Mars again. When a planet passes near the sun as viewed from Earth, we call this conjunction. And so, let me just go back to this one. Right, eventually Mars is going to be, let's go back to, so let me erase this a second here. There's the sun. There's the Earth. There's Mars. Right, if the Earth is over here, wherever the Earth is, when Mars is over here, this is at conjunction. That is to say, you would have to look through the sun to see Mars at that point. This position is opposition. Right. For an inferior planet, like Mercury or Venus, all you have is conjunctions. When Venus is here, it's in the direction of the sun, and when it's here, it's in the direction of the sun. And so this is called an inferior, So Mars gets an opposition and a conjunction. Venus and Mercury get an inferior conjunction and a superior conjunction. Right? The best time to see Venus and Mercury are when they're at maximum elongation, when they're farthest from the sun. They're still fairly close. But they're farthest away angularly. So let me go back to the... So when a planet passes near the sun as viewed from Earth, we call this a conjunction. If a planet passes between us and the sun, it's an inferior conjunction. If it passes on the other side, it's a superior conjunction. If a planet passes on the side opposite from the sun, from us, that's called an opposition. Mars gets an opposition a little every 780 days. It's like 2 years and 3 months or something like that. 2 years and 2 months maybe. The next one is on December 8th, 2022. Because Mars's orbit is elliptical, some conjunctions are better than others. So I'm just going to show you some photographs here of just the Martian surface. We have lots of probes have landed on Mars and done some interesting work. And so this is I think this is can we see that? Yeah, I think that's the rover. That's the Pathfinder, I think. Pathfinder rover. You can see the little tracks. This was in 2001 maybe, when Mars was Mars was 68 million kilometers away. So this is a cool picture. This is a little bit of what Mars' surface looks like if you're from Oklahoma. It's not too crazy looking. Here's a nice picture of the conjunctions, an opposition. Right. There we go. So here's a surface map of Mars. These globes are highly precise topographical maps constructed from millions of individual elevation measurements made by the Mars Global Surveyor. We've got a probe that was going around Mars measuring the elevation of its entire surface so we can get a good surface map. Color is used to indicate elevation. The hemisphere on the left includes Tharsis Bulge and Olympus Mons, the highest mountains on Mars. These are volcanoes here. these white objects, and they're enormous. I think Olympus Mons, which is, I think this one is the size of Missouri or something like that. Unlike on Earth, where the plates are moving and you get chains of volcanoes, on Mars you just get what's called hotspot volcanoes under a surface that's not moving. And so they just make a bigger and bigger and bigger volcano in the same spot forever and ever. And so Mars has the largest volcanoes in the solar system, at least that we know of. This is a place for a meteor strike. You can see that the northern part of Mars, this blue area on top, has many fewer craters. It was clearly resurfaced at some point since this the southern surface, which is, so they call them the northern lowlands and the southern highlands. There's many more craters on the lowlands in the highlands in the southern hemisphere, and so clearly the north was resurfaced at some point. Some geologic event happened to resurface it. Here's a nice picture of Olympus Mons. You can see the caldera there, the volcano opening. Like I said, this is the size of Missouri. The whole thing is the size of Missouri. Mars has another interesting feature. Valles Marineris is a rift valley, and for comparison, there's the United States. A rift valley, this has to do with the fact that the crust was heated from below and cracked. Unlike, say, the Grand Canyon, which was produced by a river, this was produced by heat from below, causing the surface to expand and crack. Thousands of miles long. Here are just, we've landed many probes on Mars at this point, and so there's, you can see that the pictures from various places look very similar. So Mars has some interesting features. There's been a lot of search for water. One of the underlying themes of our space missions is to look for life elsewhere. The evidence for life, if you look on Earth, anywhere where liquid water exists and a heat source, we find living organisms. And so mostly when we're looking for life outside of Earth, we're looking for a heat source and liquid water. And so, or evidence of it. Here's a nice piece of evidence that liquid water once flowed on the surface of water. That's a teardrop-shaped island. There are lots of them. And it looks like water. On Earth, we get those things when water flows past something. And so it looks like that's happening. That has happened in Mars's past. There's no water currently on Mars's surface, no liquid water. This is the Phoenix lander, which landed in 2008, and you can sort of see these were taken a few days apart, and you can see some evaporation has happened between the left picture and the right picture. That's water ice there underground. People who are speculating on the existence of current life existing on Mars are speculating that it would be underground. Living organisms have been found a mile deep on Earth, and a mile deep underground, not just under the ocean, but underground. And so it's possible that if there were living organisms on Mars, there are remaining ones under the surface. We're looking for evidence of past living organisms on the surface, and that will continue. More evidence that water once existed. And it shows an ancient lake bed and cracked mudstones. This looks a lot like what happens when we get a dry lake bed on Earth. And so it looks like there's increasing evidence that Mars had a wet surface at one time. And that's interesting because Mars's atmosphere could not now support a wet surface. You could pour an ocean there and it would just evaporate immediately or very quickly. So what happened to Mars? Why doesn't it still have a wet surface? Well, Mars is about 10% of the mass of the Earth, and it's farther from the sun, so it cooled off faster. It's lost its active geology. Remember, Earth has an active geology. Mars does not, and Venus does. And so when a planet loses its active geology, its hot interior, it loses its magnetic field, its volcanoes die. And so, so even though Mars once had liquid water on its surface, it's not there now. And so whereas Venus was a victim of the runaway greenhouse effect, where it overheated, Mars had almost the opposite thing happen. CO2 plays a significant role in trapping heat for planetary atmospheres. On Earth, volcanoes recycle CO2 into the atmosphere as it gets washed out by rain. Now humans do a lot of that, but this happened on Mars as well. However, as Mars's core cooled off, the volcanoes died and stopped putting CO2 back into the atmosphere. That caused the planet to cool. As the planet cooled, water began to condense out of the atmosphere and wash the remaining CO2 out, which made it cool off more. None of that CO2 was getting replaced because the volcanoes were dead. And so Mars cooled off more, and that meant more water left the atmosphere, and you get the idea. So unlike Venus, which was getting hotter and hotter as more greenhouse gases were getting into its atmosphere, Mars was getting colder and colder as the greenhouse gases were leaving its atmosphere. So that's the runaway icehouse effect, or maybe the runaway refrigerator effect, depending on who you ask. But that doesn't explain what happened to Mars's atmosphere. Where did it go? We know that in order to have liquid water, you have to have a significant amount of atmospheric pressure just to keep the water there from evaporating immediately. And Mars doesn't have that. So what happened to it? The loss of Mars's magnetosphere, the loss of its magnetic field, meant Mars was unable to protect its atmosphere from the solar wind. Earth has a nice big magnetosphere that we talked about that protects us from the solar wind and high energy radiation. And so slowly the solar wind removed much of Mars's atmosphere, and now it's cold and dead. So is there life on Mars? As I said earlier, on Earth we find life is found in every place where we have liquid water and an energy source. This could be deep underground, this could be on high mountains if there's liquid water, this could be in ocean trenches, just the craziest places. I don't know if they've found any place where there's liquid water and an energy source. It doesn't have to be the sun, just heat. Scientists are still looking for evidence that life existed at one time on Mars. We haven't found any now, and if we do, it'll probably be underground. These are some vehicles. That's got the wrong title. These are some vehicles that are or have been on Mars. This is a flying probe for the Perseverance, and these are two, I think for Japan, two rovers that are traveling around. Here are some questions. Hopefully you can go through these and answer these based on what this discussion was.